Estes, it is Eustace. So this is not Mr. Estes, it's Eustace. Eustace added these two fractions, and I'm going to try to make it a little bigger for us. So Eustace added these two fractions, and here's his work. So he has 1/2 plus 2/4 equals 3/6. I want you to talk with your team and decide, would you give Eustace the thumbs up? Or would you give Eustace any advice for, like, maybe he missed class yesterday, right? Maybe he wasn't with us. For those of us that are just walking in, you need graph paper out, because this whole lesson will be on graph paper, and you need your packet out. We did not check homework answers yet. We'll do that in a minute. So graph paper and get the packet out. Then talk about Eustace. Does he have the right answer? Do we need to help him out? Writing it down might help. Actually, yeah, let's go ahead and all write this down. So everyone should have graph paper out at this point. Alright, everyone with me for just a second. Everyone pick up a pencil. Put a hashtag on your paper. This is number 130. Let's copy what Eustace wrote. So we have it in our paper. So he wrote 1/2. I should see pencils moving. Plus, or I'll make my plus sign a little better. 2/4 equal to 3/6. And again, for anyone who just showed up, is his work right? Do we give him the thumbs up? Or does he need some advice, some help from what we talked about yesterday? Then we'll circle back and check the homework. So if you don't have your packet out yet from last night, pull it out. So we'll be looking at 1 to 7. Ooh, you did most of it. Did you not get to it yet? No. Not yet? All right. We're going to check that in a second. Guys, why do we not have out what I asked us to have out until I walk around? Come on. But other people have been in here for a few minutes. I'm not talking right to you, Katie. You're okay. Back it out. You might not have the homework done, and that's okay. Alright, it wouldn't be math class without a little random cards. Daniel, I can't remember if you were last yesterday or not, but this is the wrong deck. John, I can't remember if you were last yesterday or what happened. But do you want to tell us if you think Eustace is right or not? You didn't have time. That's all right. Some of us were late getting in here. Franco, have you had time to talk about this? Not yet. I know. It was weird. What creative start got here super late? Art? All right. I'll have a talk with Miss Swihart. Isabella, what do you think? Ooh, what do you mean? Tell me more.
There's no way you can really times 4 by something to get 6.
Do we see what he did do? It was wrong, but what did he do?
I'm not sure because I just...
It's all good. And what he did was wrong, so Antonella?
He just
He added. Do we add denominators together? No! So Eustace's answer is wrong. Don't go tell Estes he was wrong every year. People go, Mr. Estes. But it's alright if we do math wrong because we're learning. So let's help Eustace figure out what he's actually supposed to do. So 1/2 plus 2/4 equals, and we're not going to write down his answer because we said his answer is not correct. Kylie, what do we need before we can add fractions?
You need a common denominator.
Absolutely. You want to tell me what it could be here?
I was saying 2, since the 4 can be easily made into 2.
Oh.
Or an 8.
You're absolutely right. Guys, we don't always have to get bigger. Kylie just said, I can actually reduce my denominator here, and we could divide by 2 on top and bottom. So Kylie said, really, 2/4 is another half, right? This is really a half plus a half. Glad my voice is finally cracking. It means I've hit puberty. So what do we get when we have a half plus a half? A whole thing! Which really we could have said, before we want to write 1, we could write, we get 2/2. And if I have 2 halves, sorry, my smart board's being funky. I have 1. Yeah.
Another common denominator could be 4, so you don't have to change the second fraction either.
Yeah. Another way we could do this, ooh, I forgot I can drag these, is we could use 4 as the common denominator, times 2, times 2. This becomes 2/4 plus the 2/4. 4/4 is also 1. Cool. Get out last night's homework. I'm giving you the full high-class treatment. I did it for you. So guys, here's the thing we're all still getting used to. I don't know why we're having conversations. I don't think our binders require us to talk. I don't think we have voice-activated binders yet. Here's the thing. I know some of you don't have this done. And what is still weird is the fact that you're not in trouble, quote-unquote, because you're at a mastery school. When you are in trouble is when you don't know how to do stuff. So if you didn't get to this because you had soccer or whatever, it's fine. But if you didn't do this because you're hiding behind the fact that you don't know what to do, that's not fine. We gotta talk about this. So if you are frantically copying my work right now, that's not great. But if you know how to do it, that's okay. But really, when we get to the mastery on Friday, you're going to be asked to do this on your own. So if you have questions on these problems, you got to ask me right now. Like, that's your job. It's your job to say, I don't get this. So in our first one, for either blue or green, we don't have a spinner here. They just tell us about a spinner, right? We don't see it. So they tell us we got 3/10 green, 1/5 blue. We just talked about the fact that we wouldn't be able to add these. Here, we got to get bigger with our denominator. So we make it into tenths. I didn't have space to drop down. Sorry, so I moved it over. 3/10 plus 2/10 gets 5/10. If you didn't reduce, that's fine. 5/10 is equal to a half, though. So if you did reduce, a half is your best, simplest way to write that. Questions on 124? 125. Same sort of thing, except we do see a spinner now. I made a little red dotted line across my spinner to see how green is really 2/4 of it, which is the same as 1/2. We are on 1.2.7, by the way, on the front of it. If anyone is looking for it, last night's homework, you should, and if you don't, you need to fix it. You should have stuff written here from class yesterday. Your paper should not be blank right here. So if you don't have anything written there, you need to go back and fix that. Moving on to the back. There are lots of ways to solve these problems. This is just how I do it, because my brain says, what's been done to X, undo it. Right? Like when somebody sticks a sign on your back or whatever, we'll hope that doesn't happen. My sister used to mess with me, and she'd like stick cicada shells on me, and it's like, I put something on X, you gotta take it off, right? Like, get it back to just X. Not when I was a child. And no, still, I don't. That's a nice long answer to say. They're interesting. I don't love them. So if X had 8 added to it, we can take that away to get back to just X. Remember, if I do it on one side, we gotta do it on the other. You hopefully saw a little bit of this in 6th grade, but if you didn't, that's okay. We'll learn more about these. If a number, guys, you could replace this with hashtag if you want. If a number minus 32 is 55, guys, another way that I've seen kids like do this is say, well, what if I guess? If I say 100 minus 32, I'm too big. right? I want to get to 55. We could actually guess check our way there. So what about 90 minus 52? Well, that's too low. 32. 90 minus 32. You could guess check your way there, but a more efficient way to do it is say, well, I know what happened. 32 got taken away. If I add it back in, what was that original number? 87. I could have guess checked my way there eventually. It would have taken a while, though. This is like the guess my number thing, right? But without the words that go with it. Yeah.
I have another strategy for B.
Sure.
If you add 55 plus 32, you still get 87.
Yeah, absolutely. So then the situation we could describe C is, say, if I'm thinking of a number that when tripled is 54, right? How do we undo tripling? We divide. The opposite, well, not really opposite, the inverse in D, if my mystery number has been divided by 5, what's the way to undo division? Multiplication. So we multiply on both sides. If you have questions, please come work with me. We kind of got to move a little fast. And there aren't problems like that on your mastery. So I'm also not worried about 126 because there are not problems like that on your mastery this week. X, Y. So thank you for asking. This axis down here, oh, everything's in green, so I probably shouldn't highlight in green. This axis down here is what we call our X axis. It's the horizontal one. So you can see it right here, but it's real small. So the first number always comes from the X axis. So this number was its X location, this number, and this number was all X locations. This is also why you shouldn't do math and pen, because you make mistakes and then you're stuck with it. The other number there, where did my yellow highlighter go? There we go. They're all hiding over here. The second number is always how high up you are. So we do like left, right, and then we do up, down. So how far up is this point? It's 7 up if I trace across and see where it lines up. How far up are these other 2 points? They're the same height. They're both only 1 up if we trace across and look. This next problem is a great opportunity to show you how awesome I am at drawing shapes. I'm lying. I'm lying. I am bold-faced lying to you. What I am awesome at is using tools. So this is available to you not to take, but to borrow. These are geometry templates. I have them up in that bin right to the left of my smartboard, whatever you want to call it. If you are working on homework and would like to use one of these, borrow it in my room and put it back. These do not leave my room. Clear? They're awesome though. So come to my room to do your homework and use my stuff. I also have as many sizes of circles as you could want. Well, not as many as you could want, but a lot, right? A lot of circles. So come use my shapes templates. I even have more. I have weird shapes, like if you just want to like make a design, if you want to like tessellate things, like you're trying to make art with math. I got more templates on that shelf and back in those shelves. I got a lot of stuff. The teacher before me retired and left me all his things. So, what I care about seeing here, so if you don't have this, add it. Rectangles and squares have 90-degree angles, so they should have those little boxes in the corners. A parallelogram is only a parallelogram because the sides of it are parallel. So while we could add parallel marks on the rectangle and the square, the 90 degrees tell us that parallel relationship. We actually don't have to, but here, for the parallelogram, you need the parallel symbols. You need these arrows. Same thing with the trapezoid. The trapezoid is only a trapezoid because the bases are parallel. Guys, if you want to do yourself a favor, you could also label base 1, base 2, and the height would be the vertical dropped distance. Guys, I would label all of that if I was you. You drew yours what? Oh, that's okay. And then scalene triangle is just like a random triangle with 3 different lengths. So, not nice, right? Kind of is what we could say, not very nice. And then a right triangle has to have what? A right angle. That's what makes it a right triangle. And for 129, if you need to review how to do area, come work with me, please. I would be happy to do that with you. I'll probably take a separate video of it. So it's a quick little one-off video. Any remaining questions? I know I covered homework a bit more thorough today than previous days because this was a pretty important homework. I will show you the mastery at the end of class today so you know what to expect for Friday. Okay? Yeah. For which one? For the triangle, 56 times 73. Oh, you forgot to divide by 2. So you did your base times your height, but remember the trick with the triangle is it is half of what the rectangle would be. Because remember, if we just did 56 times 73, it's like it's a rectangle. So then we have to do half of it. So when we divide by 2, that's how we get the 2044. Does that make sense? Yeah. I'd have to check your work. So guys, that's why it's nice to have your work written out. So the numbers we should be multiplying to do the triangle. Let's just do this. I always write my formula first. 1/2 times base times height. The base and the height we can find because the right angle tells me this is my base, this is my height. So double check were the numbers that we multiplied with the 56 and the 73. So we're going to do half of 56 times 73. And to make sure I don't goof it up in my calculator, I do a piece at a time. So if I do 56 times 73, I go ahead and hit enter. And then I either do times 1/2 or I can divide by 2 to do half as well. So double check the numbers that you used. I'm guessing either it was like a calculation mistake or a numbers mistake. All right, at this point, go ahead and put that away. We just need graph paper out for today. If I say penny candy, am I just too old these days for anyone to know what penny candy is? Do you know, Dishita? So what I'm talking about, and you guys might be mad that you don't know about this or that you haven't like experienced this. Penny candy is candy that literally costs a penny.
What?
So yeah, I know you're all like, "There's no way candy doesn't cost a penny." So there was a store in Coshocton, where I'm from, called Collins Meat Market, where we'd always go. It was like a deli, and we would ride our bikes down there and stock up on the little colored, like Tootsie Rolls. You know, like the flavored Tootsie Rolls. Yeah, they were a penny. Yeah, I'm getting old now. I feel like it. So like that, we've got Tutti Frutti Chews or Fruity Tooty Chews or whatever they're called. In 3 different fruit flavors. Ooh, ah. So, Lindsay says, if you reach into the bag, you're going to have a 1/3 chance of pulling out killer kiwi. There's a 3/5 chance you're going to pull out coconut. So, if you reach into the bag, what's the chance of pulling out either, because, you know, you like either of those, either coconut or kiwi. Work with your team. I bet you only need 2 minutes to do this. Have at it. We should be writing things on our graph paper. We should be writing things on our graph paper about this problem. You just really like using patterns. It's like,
They're more flowy. So there's coconut,
with an or situation. And guys, you could make this note in your notes. I would if I was you. Coconut or kiwi. What does or have us doing? What? Yeah, we're going to add because we want either of them. Go ahead and keep working with your group. I'm going to write a couple things up here. This is what I was trying to remember this morning. Okay, so put that like right in your mind or somewhere convenient that we can come back to it later. All right, bring it back together. Eli, can we add 1/3 and 2/5 as it sits right now? No, why not? We need a common denominator. Layla, graph. What would be a good common denominator here? Is it 3/5? Ah, it is 3/5. Good catch. See me after class. You get a piece of candy for catching my mistake. Because that was a legit mistake up here. Yeah, guys. Keep your eyes open. You catch my mistake. Might get rewarded for it. So, what's a good common denominator? 15. So what do I multiply by here to get there?
5.
Say it better, like we said yesterday.
5/1.
5/5, right? We're going to say we multiply by 5/5. Because, guys, really, if we're writing this how we should, we're multiplying by the fraction 5/5. Double check your work. What do I multiply by here?
3/3.
Ah, 3/3. And then if we come down, I'm going to change colors because we're new numbers. We're the same, but we're new. 5/15 plus what? 9/15 equals 14/15. So, Lucas, does there need to be a third color in the bag?
Yes.
Why?
Because 14/15 does have a hole. So there has to be a hole.
This is not the whole thing. Guys, probability has to add up to 1. Otherwise, there's something missing. And like, well, what is it? There's like a black hole inside the bag. If you're reaching to just the right spot, you just like disappear. No, like that can't happen. I mean, black holes exist, but there's no black hole in the bag of Tutti Frutti, Chewy, whatevers. So, if there's a third color, take 30 seconds to talk with your group. What's the probability of that third color? Everyone just said that real loud.
That's just a random one. You don't know what that flavor is. Just a random flavor.
Yeah, everyone said it real loud, so I don't even really need to call on anyone. If we start with our whole, the total, that's 1. And we can make that any number over itself. And then we take away what we got, and the final color remaining, or flavor, has a probability of 1/15. Be careful. Questions. We have to have everything to be done, right? Like to have the whole situation. I don't know if they told us. Maybe we got to do another problem to find out. So, question for you guys, though. Okay, we'll throw this to somebody. Antonella, do you think there could be 30 pieces of candy in the bag? Why? You're right. Ooh, we can keep adding the equal amount. So, Marina, do you think we could have 20 pieces of candy in the bag? Actually, hold on, don't answer. Everyone take a second, not with your team in your head. Could our bag have 20 pieces of candy? Our denominator is normally talking about our total, right? So Antonella said, I can add another 15 because it's an equal amount to what I had. But if we have 20 pieces of candy in the bag, can I make 1/15 turn into something over 20? Mathematically, sure, right? I can do that. But am I going to have a whole amount of pieces of candy then? No. So this gets into situations where, like, can we do something becomes a tricky question, right? So we couldn't have 20 pieces of candy here. If this is our probability, 1/15 and like 1/3 and 3/5, we can't have any random amount of pieces of candy. It's got to be a kind of specific denominator. Questions on that? We'll do more with this. I'm just trying to get the idea out there to you. The denominator can be specific. So, give me another total. Those are all blank. You're absent. Farah, give me another total we could have that's not 30. Ooh, that would actually be a little tricky. Antonella? 60 would work. 45 could work. 60 could work. Guys, essentially, you're thinking of multiples. We want to double the bag, or triple the bag, or quadruple the bag. We got to work nicely. But this is a new idea, right? This is a brand new idea. So, new bag. Draw a squiggly line. Draw a squiggly line. Or you can make it a straight line if you want. I'm a squiggly person. Katie's like, I'm not going to draw any line. Forget you. Whatever. 132. This is number 132. Ooh, smartboard. Come on. All right, I do have one complaint about my smartboard, I guess, since we were talking about it before some people came in. All right, write this down. We got a 2/7 chance of drawing red. We got a 2/7 chance of drawing a red marble. We have a, now listen, 2/3 chance of drawing red or blue. What is our chance of drawing a blue marble? You guys are welcome to read what these students suggested, but if you want to just start talking to each other, you can. How could we figure out just blue's probability when they tell us blue and red is 2/3 and just red is 2/7. I'm going to write this stuff down here. So again, somebody in your group, you guys might want to get in the habit of, like, it's beneficial if somebody in your group has a book. But it's okay if you don't. I'm just going to scroll this a little bit. 2/3 together. So guys, what I'm writing down should be on your paper. If it's not, get it on your paper before I start walking around. You got a moment, because I'm going to take a drink of water. I think red is 2/7. I don't know if you can see from back here, but I think you have 2/5 written down. Yeah, 2/7 for red. So red is 2/7, or is 2/3. Do we think we need to add here or subtract here? Could we add? Maybe. Isn't subtraction just addition? Sure. What's not okay is that you didn't write down their common denominator forms. This symbol is actually incorrect too. So we don't cross multiply here. So if that's meaning cross multiplication, we need to erase that actually. So I need you writing down what we write on the board. And what we don't have that I wrote on the board is that here we multiply by 5 on top. And 5 on top. Yeah, so it's not there. This is where we cross it. This is not a situation. This is why.
Okay. That seems to be the confidence around here.
how did we get an OR probability? Like on the last slide or 2 slides ago, or yeah, like how do we? I guess I can go back a slide or 2. This was OR, right?
Yeah.
How did we get it?
Well, what I did was I did
I'm probably asking a different question than what you're trying to answer.
for the one that you answered before.
I can come back to you.
I think she wants to answer the other question.
Yeah, I know. So I can come back to you. I'm trying to build what we need to do. Guys, anybody, what did we do in an OR situation? We added. So what we need to think about here, which a lot of you probably jumped over, which is okay if you knew what you were doing. Smartboard. Is that the probability of blue gets added with the probability of red. So guys, I would write this down. You should write this down. We know one of these. Which of these do we know? The red. So what are we trying to figure out? The blue. Do these fractions work nice together right now? So I'm going to drop my page and again write exactly what I just wrote. So if you don't have it, here's another chance to write it. What we're thinking about is the probability of blue plus the probability of red is what they told us equals 2/3. If the probability of red is 2/7 right now, what's a common denominator I should use? 7, 14, 21. So how do I turn this into 21? Times 3 over 3. 6. Well, I might as well just write this in red. 6 21sts is my probability of red. How would I turn 2/3 into times 7 over 7? Making this really, how many 21sts? 14. And then how can we figure out what blue is gonna be? You guys already told me. All of you said we're gonna need to subtract, right? Or we can kind of think of addition, right? What needs added with my 6? I mean, we can kind of think of it like that. But if we go this way, we can just kind of subtract. What's 16, or blah, 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 what's 14 minus 6? 8. So we figure out this has to be 8. So on your practice tonight, and we'll go over your practice tomorrow like we did today, like really in depth. On your practice night, you're going to practice subtracting probabilities. Okay? Thank you very much. Pack it up, head out. Have a good one. Do the current work, and then if you get that down at any time in the over, do something right? Do a question or something, just a little bit. Top priority is still No question. You have to have work around here. And if you can't finish this, you have to come back to me with a question. Okay? This is not a negotiation. This is what has to happen to get you caught. Right? I've been at this for 10 years. You gotta trust me. You have to tell yourself this has to be a priority tonight. Else you're not gonna break this down. Okay? Alright, thank you very much. Huh? Ah, dang it. Sorry, you. I had too much stuff in my head floating around. My bad. I didn't even pull the cards back out, honestly. Then we just rolled through the end of the problem.
I think Layla already left, but you did overall, I say. Right?
I know. Why'd she leave? Tell her to come back.